Hi everybody, Professor Jim here at County College of Morris in Randolph, New Jersey. I want to welcome everybody. Today we had some student questions, so we're doing a little question and answer session. We're going to first go over order of operations, exponents and square roots, and then we'll go into some other topics on the next video. Okay. All right, we'll start with order of operations. Order of operations is just a sequence. It's a bunch of steps. There's 6 different steps. So it's not a lot. I would call not a lot a good thing, but that's my opinion. Okay, anyway, the first thing, we're going to go left to right. And the first thing we're going to start with are parentheses, or brackets. The first set of brackets we'll deal with the rounded brackets. Second set we'll deal with, they're kind of squared off brackets. And these I just call fancy brackets, the big brackets. So we'll go left to right with that. I'll put up an example for us to go over. Okay, here's an example with a whole bunch, well, 3 groups of brackets. Okay, so first things first, rounded brackets. Okay, whether they're adding, subtracting, multiply, or divide, whatever they happen to be, we'll do the rounded brackets first. Okay, so 4 times 3, we got 12. Plus sign in here, in the middle. Okay, so this will be minus 6 plus 3 times 5 minus 2 will be 3. Okay, and we're going to add these. Put a plus in there. Okay, easy enough. So far, so good. Okay, we did the rounded brackets. Now we'll do the square brackets. 3 plus 12, 15. That's the first bracket. We have multiplication, we have subtraction. If we don't have exponents, we don't do exponents. If we don't have division, we don't do division. Whatever you don't have, you don't have to do. Okay, so 3 times 3 is 9. Minus 6 plus 9, minus 9. That's plus 9 minus 9 makes it easy. Okay, so we have 15. Minus 6, right? We have 15 left hand squared bracket. We have minus 6 right hand squared bracket. 15 minus 6 is 9. Big fancy brackets at the end. So our answer for all this, our answer winds up as 9. And that's order of operations. Now we're going to go into exponents, which is also part of order of operations. We didn't have exponents here. And we're going to go into square roots. Anything can be part of order of operations. They could throw a square root in here. We can put that under, square roots somewhat like division. A lot of times order of operations, they'll keep square roots as its own thing. They'll keep square roots together and do a square root problem. Okay. Exponents are made up of 2 parts. One part, the main part, is called the base. And the superscript up on the right is called the exponent, or power. Either one, same thing. Base, main, same thing. Okay, so the exponent or power tells us how many times to write down the main number. So in this case, it's a 2. Okay, so we write 10 down twice. And then we multiply. So we get 10 times 10, we get 100. Okay, easy enough, right? 10 to the third power, you can do the same thing, right? Ten to the third, the 3 shows us to write 10 down 3 times. We write it down 3 times, we multiply it. So we have 1,000. All right, so far so good. I'm all dressed up for this occasion. Okay. So where are the tricks? Well, here are the tricks. There's a few of them, not that many. There's 2 of them. Any number to the first power, whether it's 10 or a billion, equals the number itself. So if you have 5 to the first power, you have 5. If you have 20 to the first power, you have 20. Okay, that's easy. That's not a trick. Okay, so what are the 3 tricks? There's only 2 on the board. Only 1 on the board is a trick. We'll have 2 more in a second. Few seconds. Anything to the 0 power counts as 1. Whether it's 10, 50, 70 billion, 900 trillion, whatever number it is, to the 0 is equal to 1. Okay, that's fairly standardized. What if it has a minus sign in front of the exponent? Okay, now that's tricky because that's different than the other ones. It doesn't tell us to write, does it tell us to write 10 down negative 2 times? What it does, if we get a negative sign, is we drop the main number into the denominator. And we change the sign. So if it's 10 to the minus 2, we make it 10 to the second power in the denominator. And we have the same old numerator as 1. So we put a 1 over whatever we're looking at. We take what we're looking at with the minus power or minus exponent, move it to the bottom, and change the sign to make it positive. Okay, so this is the same as 1 over 10 times 10, or 1 over 100. All right. Trick number 1, anything to 0 power, 1. Trick number 2, anything negative power, drop it into the denominator, put a 1 on top in the numerator. Okay. Trick number 3. Okay. Negative 3 to the second power. Doesn't look so bad, right? It's not so bad, but it's a trick. So we just have to make sure we keep track of the minus sign. All right. Minus 3 to the second power, no brackets, no rounded brackets. So what this tells us is that the 2 tells us to write 3 down twice, right? Just like the 2 told us to write 10 down twice. So we do the same thing. So we go, okay, fine, I'll write 3 down twice. We're only looking at this part of it. We're not looking, there's no bracket. So 3 twice is 9, right? And then we have the minus sign in front. So we have to bring that back into the game. So our answer for minus 3 to the second power is minus 9. For those of you who use my math lab, you'll probably run into something like this. Okay. Or if you don't use my math lab, you'll run into it in a book. Because they like putting that minus sign in front because it's confusing. But we have our video here, so it's not going to be confusing. Okay, now minus 3 in its own bracket. Just like when we had parentheses, we did the rounded brackets first. This minus 3 in its own bracket, the whole thing, the whole minus 3 is now the base. And the 2 is still our power, or exponent. Okay. The 2 superscript tells us to write minus 3 down twice, right? So we do. Minus 3 times minus 3. minus times a minus is a plus. That's proven with calculus. We're not doing calculus today. We'll just take it for granted that that's calculus. Okay, so minus times minus is a plus. All right, 3 times 3 is still 9. Hasn't changed in a long time. Okay, so our answer for minus 3 in a bracket to the second power is positive 9. And our answer to minus 3 with a second power with no bracket is a different answer. It's minus 9. So keep an eye on the minus sign and keep an eye on brackets. You got brackets, the whole thing's the base that's inside the bracket. You don't have brackets, just the number, the big number is the base. Superscript is still the power or exponent. And that sneaky minus sign you have to bring back in there. Okay, so that's exponents. So we covered all 3 tricks and regular stuff. Regular first. Tricks, anything 0 is 1, minus, sinks everything to the denominator, put a 1 on top, and keep an eye on these subtraction signs. Now, except for the minus sign with the power, the exponents are making numbers bigger. Now we're going to look at roots, square root in particular. We can think of square roots as the opposite of exponents. If we have a phone, then the phone overall that's working could be we can consider an exponent. And the square root would be we'd have the phone apart in all its pieces, in all its different parts. And then we put the parts together and we wind up, getting the whole phone. Or in this case, we have the whole phone together, and now we take the parts apart. And we take the phone apart, and we get the parts. So that's what we're doing with the square root. Now, square root has 4 steps. I'll pick a number that's not too small and not too big. So let's pick 72. Now, for a square root, if you have that little 2 in there, that right in this square root sign, you can have 2 in there, or you could have nothing. Either one's okay. They both mean square root. Okay, so for this, let's put steps over there. Oh, it's all right. We can use a tree diagram, also known as a number tree. Okay, what do? They show the bigger number, and then they show the prime numbers. Okay, why does that matter? The prime. Why does it matter? Well, there's a few reasons why it matters. One, we want to know how to simplify the square root. 2, we use prime numbers a lot for greatest common factor. We also use prime numbers a lot for least common multiple. Because the prime numbers are the numbers you can just divide by themselves and 1. And they're the building blocks of everything else. We don't start with a number like 87,943,826. We start with smaller numbers. Okay, so let's pick 72. Okay, even number, right? So if we divide it by 2, we get 36. All right, 36, even number again. Go down the number tree. 18 times 2 is 36. As you go up the tree, you take all the smaller numbers and multiply. You wind up with the bigger number on top of the tree. 18, break out to 9 and 2. 9 is 3 and 3. Okay, steps. That didn't come out right, did it? Try again. Good thing about math, you make a mistake, you can erase it and start over. All right. It's not like doing surgery or anything. Okay, so that's good then. All right. first thing we did, number tree, got the bigger numbers shown as all the smaller numbers. 3 times 3 times 2 times 2 times 2 equals 72. All right, second thing we do is we look for pairs. I like circling. Other people like underlining numbers. Some people like putting arrows on things. Whatever works for you. You can put triangles around them. Whatever makes you happy, whatever makes it easy to figure out what works is what you can go with. I like circles, so I'll go with circles. Look for pairs. Well, we have a pair of 3s, circle that. And we have a pair of 2s. Okay. So the third step, show the third step is going to be show one representative, can't say that 5 times fast, of each pair outside the square root sign. Okay. So we have a pair of 3s, that'll give us a 3, right? Need some room here. And we have a 2. One rep for the pair of 2s, we put that outside. Okay. And the fourth thing we're going to do the ones that don't have a pair, in this case it's just one number, we'll keep that inside the square root sign. So this will be inside. With the numbers for the pairs, we'll multiply them if we need to. If there's more than one number on the outside, we'll multiply. If there's not more than one number on the outside, we just keep that number. All right, so we took 3 times 2, we got 6. And then we have square root of 2 inside. Put a little 2 in here. How do we know if we have the right answer? We don't. Ha, no, kidding. We know if we have the right answer. Square roots, right? It's the opposite of exponents, so we do the opposite. We take the outside number, we square it, right? That's the opposite of a square root. 6 times itself is 36. Then we multiply it by the number on the inside. And we get 72. And that's the number we started with. That way we can double check ourselves. And we'll know that we had the right answer. Always a good thing to have the right answer. Okay, if you make a mistake in between, that's okay. Don't panic. Please don't panic. Just erase things and just redo things. Okay, it's math. I know a lot of people have a hard time with math. That's why I'm doing these videos. I'm helping people out with math. Okay, so that concludes order of operations, exponents, and square roots. Any questions? Okay, so we're good. Hi everybody, just wanted to give a few shout outs. Wanted to thank our sponsor, Luigi's Pizza, which is in Susquehanna, New Jersey on Route 10. Go see Paul, tell him I said hi. And now they have the traditional menu back, like the retro menu, and you can go see them. I also wanted to give a shout out to Santana's Hair Salon, which is also in Susquehanna at Roxbury Mall. And a quick shout out to Knight's Automotive, which is in Ledgewood section of Roxbury on Main Street for all your car and truck needs. Thanks.